Okay, so this is homework number 6, the benchmark review. A little before our CDB, that's tomorrow. All right, so it says the coordinate A 6,5 is translated 8 units to the right and 6 units down. So we're looking for the distance from the coordinate before and after the translation. So if we're at 6,5, 6,5. So here it's going to be in that area. Whoops. Going to be here, 6, and then go up 5, right there. All right, so now if we look and we say, well, it's going to go 8 units to the right, like that's going to go off the graph, and you're right. So if we go 8 units to the right, just pretend like we have a straight line, and we really don't need 8 units to the right. Let's just say that's a straight line that we got there. That's 8, right? 8 units to the right. Oops. And then if we go 6 units down, about like that or so. Okay, there's my 6 units down. We're going to be looking for the distance between these two. So, you know, something like that. I mean, obviously you know it connects, but so if we're connecting these two, we'll just put this little dot right there. There we go. So if we're connecting those two, then we just got a Pythagorean theorem question. Okay. All right. Okay, so number 2, write an equation for the line below in slope-intercept form. So just an equation. That's what we're looking for. Okay, question number 3, are the two triangles shown below similar? So we've had a question like this before, so it's going to be yes or no. You need to find out those other angles on there and see if they're similar triangles. All right, number 4, find the volume of a sphere with a radius of 2.5 inches. So volume of a sphere, radius is 2.5, so I mean that's really 2.5, okay? And of course, you should probably know the formula by now. 4/3 pi times the radius cubed. All right, number 5, write an algebraic representation of a shape that has been rotated 180 degrees clockwise. So x, comma, y, and then you're going to find out what the next part of this representation is going to be. So 180 degrees clockwise. Okay, question number 6, write an algebraic representation of the dilation shown below. So this is a dilation. This is like what we did on Monday in class. A dilation review video I also put up. So this is going to be new over old. Okay, find the points that you would use and then get your scale factor and then just put that in front of x and in front of y. All right, number 7, calculate the lateral surface area. So lateral surface area of the triangular prism. Okay, so I know that my base I'll use is the triangle in there. So there's that. And then this is my height in between the two. All right, so since we're looking for lateral surface area, it's really just going to be the perimeter of the base multiplied times the height. All right, number 8, what is the surface area of the triangular, this should be rectangular prism, okay, of the rectangular prism shown below. So we're looking for surface area. I can use this as my base. So if I'm going to use that as my base, that's going to be my height. Surface area, perimeter of the base, multiply upon the height, plus 2 times area of the base. Here we go. Okay, number 9, calculate the volume of the cylinder below. Volume of the cylinder. Okay, so our formula for volume of the cylinder is going to be area of the base multiplied by the height. So area of the base is pi r squared. Radius for this is going to be 5 because we have to multiply, or divide actually, that 10 by 2. And lastly, number 10, calculate the lateral surface area of the same cylinder shown above. So the same cylinder that we used on number 9. We're going to do the same thing, but this time we're looking for lateral surface area. Okay, so again, the radius we mentioned earlier is going to be 5. Lateral surface area of a cylinder, if we look on our formula chart that you'll have tomorrow, it's 2 times pi times the radius times the height. That's it.